Hey, it's probably time to stop recommending clean code. Is this not the most like milquetoast take you can have? It should just be called stop recommending clean code. Maybe we should consider possibly not doing clean code. We're going to get in there, okay? We're going to get in there, and I'm going to just say this. Stop recommending clean code, okay? It may not be possible for us to ever reach empirical definition of good code or clean code. Absolutely, which means to say that any one person's opinion about another person's opinions about clean code are necessarily highly subjective. This is true. This is very, very true. And by the way, I did forget to say some thank yous. Flip, take this out. Flip, take this out. Flip, take this out. Hey, Dwarzy, thank you very much for that. And Prozac, thank you for those gifted subs. I appreciate that, okay? I appreciate that. Sorry I didn't say thank you to begin with. All right. Oh, shoot. I don't even know where we're at. All right. Let's see. Pick up from here. Okay. There we go. There we go. All right. I cannot review Robert C. Martin's 2008 book, Clean Code, from your perspective. Only mine. I never liked clean code. Still don't like it. That said, the major problem I have with clean code is that a lot of the example code in the book is just dreadful. Asterisk. In Chapter 3, Functions, Martin gives a variety of advice for writing functions well. Probably the strongest single piece of advice in this chapter is that functions should be not mixed levels of abstraction. They should not perform both high-level and low-level tasks. Because this is confusing and muddles the function's responsibility. I like that take. That's a good take. I mean, really, your function should approach close to single responsibility. Approach. And what I mean by that is that, when someone gets really into clean code or really into things, you start seeing this really almost like Lego level dissemination of how information works, and it gets super spread thin. And sometimes that's really hard to work with, right? There's a level of abstraction. There's a level of things you should be doing that, there's definitely a curve. There's too much atomization, it gets difficult, and too little atomization, it gets difficult. But there's like a middle ground where it's really nice. Personally, what I find, my general rule of thumb is this, is that a function should do a concept. That's like my general rule of thumb. And if this concept if inner concepts come up many times, I will refactor out that inner concept into its own thing. But in general, I keep at a conceptual level what it should be doing. So that means if I need to go fetch all the video frames for a video, sort them, and give you the highest, the highest encoding time for a video frame, then what I'll do is I will actually do all those in a single method, right? If that's what I'm doing, because that's just the concept. I'm just going to do that. And until I need to fetch video frames many times, I'm not going to pull that out, right? I just kind of keep it into this really, whatever. There's let's see. There's other valid stuff in this chapter. Martin says that function's responsibility. Let's see. They should not perform both high-level and low-level tasks because this is confusing and muddles the function's responsibility. There's other valid stuff in this chapter. Martin says that the function name should be descriptive and consistent and should be verb phrases and should be chosen carefully. I probably don't choose these things as carefully. I'm not sure if I do verb phrases. Well, this seems really loud. Wow, this is oddly loud. I don't know how well I name my functions because a quarter of the time I just want to say, these nuts jokes, and it kind of ruins my ability to name good functions. You know what I mean? Does that ever happen to you? Where it's like you should be responsible, but instead you're naming it D's nuts. Later, TJ. Later, Teach. He says that functions should do exactly one thing and do it well, which I agree with, provided that we aren't too dogmatic about what we define as one thing. Yeah, so I'm on this camp. We have to understand that in plenty of cases this can be highly impractical. He says that functions should not have side effects. I disagree with that, and he provides really a great example. And that, and that output arguments are to be avoided in favor of return values. Yeah, I would agree that output arguments are generally a bad idea. Generally a bad idea. You know what I mean? Generally. But sometimes they're not. He says that functions should generally, should either be commands, which do something, or queries, which answer something, but not both. Okay. This is all reasonable entry-level advice. Yeah. I go kind of back and forth, right? whenever, like, the tool I'm building right now, we're up to like 40,000 lines of code. Most of it is just like a bunch of Legos. And then I build up this, then I have these like entry point, these functions, these commands you can run. And those tend not to be very, those tend to be a bunch of stuff all kind of muddled together. And that seems really reasonable. Because like when it comes to like these, it's almost like UI code. It's just like you kind of just got to do a bunch of shit to get this thing done. And breaking up any further is really inconvenient. So I always have this hard time of when do you break this rule? Because there is a time you should break the rule. And it's not obvious. And sometimes it's even better to break the rule intentionally when the thing is small and grow it as you want it to. You know what I mean? But mixed into this chapter, there are more questionable assertions. Martin says that Boolean flag arguments are a bad practice. They can be annoying, which I agree with, because in an unadored true or false in the source code is an opaque and unclear version of explicit is sweet and is not sweet. Yeah, but Martin's reasoning is rather that Boolean arguments mean that the function does more than one thing, which it shouldn't. Yeah, I disagree with his reasoning why. I generally do try to avoid Booleans because they truly are confusing. And every time I do a Boolean flag, it's not that they are confusing. It only takes a moment, right? Like, I think a lot of these things that are written really don't have in perspective something like something like an LSP. That's just going to help you right away so you know exactly what you're getting, right? And so Boolean flags don't bother me because I pop it up and I can see right away, do this thing. And I can see right there and I go, okay, this is what that Boolean flag does. But the problem with it is that whenever I write a function like that, inevitably it seems like I always have to abstract it further and I have to add yet another Boolean flag. It always seems like I've done something wrong and I can't describe exactly why. Yeah, it's like a named argument effectively. And so I have this problem where I know that it's wrong, I just can't, it's a hint. I just can't quite tell what the thing is that's wrong. And so I don't know. Martin says that it should be possible to read a single source file from top to bottom as a narrative with the level of abstraction in each function descending as we read on, each function calling out to further functions down. This is far from universally relevant. Many source files, I would even say most source files, cannot be neatly hierarchized in this way. Yeah, I'd agree with that. Even for the ones which can, an IDE let us trivially jump from function to function. Yes. I wouldn't organize it that way. Generally, I try to organize things in a very simple manner, right? Like type definitions up top, functions down low, right? As simple as that. Like I don't try to be super dogmatic about things. I try to define functions that I use within the function lower down. I think that's a good practice in general, but that's about it. You'll understand soon that every language you've ever used is trash. Yep, every language you've ever used is trash, specifically JavaScript. He says that code duplication may be the root of all evil in software. That's always the misquote. Do you know people have never quoted that phrase correct? We gotta get, someone has to be able to quote this thing correct. At some point, one of us is gonna do it correctly. And fiercely advocates dry. At the time, this was quite the standard advice. In more recent times, however, we generally understand that a little duplication isn't the worst thing in the world. It can be clear and it can be it can avoid cheaper than wrong abstraction. Yes. So I totally agree with this, that you should never do this. I did this for a decade. Like a decade. Dry is the root of all bad code. Dry is the root of all bad code for 100%, because what ends up happening is that you consistently and continually abstract things. It's so annoying. It's so annoying. Then it gets weird. Martin says that functions should not be large enough to hold nested control structures, conditionals, and loops. How do you ever program then? Equivalently, they should not be indented more than 2 levels. He says that blocks should be 1 line long, consisting probably of single function calls. He says that the ideal function has 0 arguments, but has no side effects, and that the function just 3 arguments is confusing and difficult to test. More bizarrely, Martin asserts that the ideal function is 2 to 4 lines of code long. This piece of advice is actually placed at the start of the chapter. It's the first and most important rule. I actually find all of this incorrect. Virtually everything he says is incorrect. My general rule of thumb is set an 80-column limit right here. By setting an 80-column limit, you're going to know when you're probably indented too much. And I do mean that. This 80-column limit is going to give an early warning sign that you've exceeded an amount of indentation that maybe isn't worth it. It's also a reason why I don't use 2-space indenting. 2-space indenting just makes me write more nested code because I have more space to go. And so I just use this as a soft rule for myself, right? So this is a soft rule right here for me to just know how much to do, right? I find that, I like it. Let's see. And when is a function too big? I don't have a strong opinion on when a function is too big. I don't. I have no opinion on when a function's too big. A function is too big when it has too many concepts. And I'm fine with a function with 2 concepts sometimes, Sometimes you got to do it. Zero argument thing only makes sense in a world in which you're strictly building basic nothings. 100 lines is too long? Is it? Is it? I don't know. I can't tell you what's too long. Right? It's hard. It depends on what you're doing. Let's see. The first rule of functions is that they should be small. Then the second rule of functions is that they should be smaller than that. That is not an assertion I can justify. I can't provide any references to research that shows very small functions are better. I find it the opposite. In fact, just me in my general outlook of life, I find this more confusing, significantly. What I can tell you is that nearly for 4 decades, I have written functions of all sizes, and I've written a nasty 3,000-line abominations. I've written scans of functions with 100 to 300-line range, and I've written functions that were 20 to 30 lines. What the experience has taught me through long trial and error is that functions should be very small. Yes. When Kent Beck showed me the code, I was struck by how small the functions were. I was used to functions in swing programs that took up miles of vertical space. Every function in this program was just 2 or 3 or 4 lines long. Each was transparently obvious. Each told a story, and how each led you down to the next compelling order. That's how short functions should be. It's again, I feel like this advice is totally lacking a bunch of stuff. I don't know about that. Like, here's a good example. Say you have a complex type, a crash report type, and you need to display the crash report. Like, that function that displays it, say, in a CLI application, it could be quite a few lines long, because CLIs that are just printing stuff out, you could have many log statements to get to that point. And you may have to do a bunch of little assertions all the way through. And so it's like, is that bad? Is that good? I don't know, right? Of all things, like all of this sounds like hyperbole. Case for short functions instead of 1 long ones can certainly be made, but we assume that Martin doesn't literally mean that every function in our entire application must be 4 lines or less. Yeah. Let's see. But the book is being absolutely serious about this. All of this advice culminates in the following source code listed at the end of the chapter. Okay, here we go. Do I zoom out to see it? See, like this stuff, I hate this kind of stuff. When I look at this kind of code right here, like, emotionally hurts me, because there's so much context I have to set up in my brain to understand what's happening. Do you know what I mean? Like, if we just look at this one, include setup page. Like, look at this. Include setup pages, which calls this, which if it is this, it has to do this, or it has to do this. Like, you have to hold a huge amount of context in your head, and I do not believe in any sort of way this is easier to follow, right? Right? Like, that kind of, like, this hyper smallifying of code, it becomes 10,000 times harder. Honestly, how hard would this have been if you would have taken here? Let me just go like this. All right, so here's that code. How much easier would it have been if I would have just done something like this, right? I don't even know what include page does. What does that do? Includes page setup. All right, right, like, you kind of just know what's happening right here. I didn't have to jump 5 functions to figure out what the hell's happening, right? Or is that both? Oh, it is both. You're right, it is both. There you go. I didn't have to find out what the hell's happening. You know what I mean? Like, this is just so much easier to read than several functions of jumping. That's if it's used everywhere, then you abstract that concept. But it first has to be used everywhere, right? That's why Martin Fowler has this really a beautiful thing, which is when you repeat yourself 3 times, then refactor, right? That's a beautiful rule. Like, and here's the deal. How do you know this is repeating itself? Like, it's incredibly difficult to figure out. This one is not repeating, so this is not a repeat. This is not a repeat. You have to use function references to figure it out if it's repeating itself. So I do not, I hate that stuff. I hate it. I'll say it again. This is Martin's own code written in his personal standards. This is an ideal presented to us as a learning example. This is true. This is an ideal, right? I will confess, at this stage, I like my Java skills are, that my Java skills are dated and rusty, almost dated as rusty as this book, in which is from 2008. But surely, even in 2008, this code was illegible trash. I would agree. Let's ignore the wildcard import. First, the class name, setup teardown includer, is dreadful. It is at least a noun phrase, as all the class names should be, but it's a noun verb phrase, the strangled kind of class name you should invariably get when you get working on a strict object-oriented code, where everything has to be a class, but sometimes the thing you really just need is a simple gosh dang function. Dude, for real, setup teardown includer? This doesn't even make any sense. Inside the class, we have 2 public static methods, as before, plus 1 private constructor, plus 15 private methods. Of the 15 private methods, 13 of them are either, 13 of them either have side effects. They modify the variables which were not passed into them as arguments, such as build this, which have side effects on new page content, or call out to other methods which have side effects, such as include, which calls this. Only is test page. Find inherent page looks for side effect free. They still make the use of variables which aren't passed into them, page data and test page respectively. But oh my goodness, yeah, it's this is such a cluster festival, right? This is a great function. I'm fine with that function. There you go. That's a great one right there. I'm fine with that. But some of these things are just so painful. Like all of this stuff is just so this is so hard to read. I just hate this idea of clean code. Anyways. At this point, you might reason that maybe Martin's definition of side effect doesn't include member variables of the object whose method that were called. If we take this definition, then 5 member variables, page data, is suite, test page, new page content, page color, all implicitly passed to every private method call, and they are considered fair game. Any private method is free to do anything they like of these variables. Exactly. So another reason, this is more of a stab against OOP, which is the effect of methods and what they have implicitly passed to them can be very large, and it can, classes can be very tricky. I like classes, don't get me wrong, but they can also be tricksy. But Martin's own definition contradicts this from earlier in the chapter. Side effects are lies. Your function promises to do one thing, but it does another hidden thing. Sometimes it will make unexpected changes to variables of its own class. Sometimes it will make them to the parameters passed into the function or to the system globals. In either case, they are devious and damaging mistruths and often result in strange temporal coupling and order dependencies. I'm fine with functions mutating state of a class. Am I the only one? Is that crazy? Is that crazy of me to think that? Put the ass back in class? Hell yeah. Is that crazy of me to think? That, I don't know. I like this definition. I agree with this definition. It's a useful definition, but it enables us to reason about what the function does with some degree of confidence. He said unexpected. I mean, it's always unexpected because you don't know what something does until you know what it does. Is that a truthism? Yeah. By referring to only its inputs and outputs, I agree. It's bad for a function to make unexpected changes to the variables of its own class. I mean, is there any unexpected changes? So why does Martin's own code, clean code, do nothing but this? Rather than have a method pass arguments to one another method, Martin makes a distressing habit of having the first method set a member variable in which the second method or some of the other methods then reads back. That makes it incredibly hard to figure out what any of this code does. Yes, because of all these incredibly tiny methods do almost nothing and works exclusively through side effects. Agreed. Cascading side effect programs are very difficult. Let's just look at another one of his private methods. This.isSuite. Okay, so render sets the suite. If it's a test page, include this, return this one, get the HTML. So you can imagine that that someone enters a kitchen because they want to show you how to make a cup of coffee. As you watch carefully, they flick on the switch on the wall. The switch looks like a light switch, but none of the lights in the kitchen turn on or off. Next, they open a cabinet and take down a mug to set on the worktop and then tap it twice with the teaspoon. They wait 30 seconds and finally they reach behind the refrigerator where you can't see and pull out a different mug. This one is full of fresh coffee. What just happened? What was the flickering switch for? What tapping? Empty mug part procedure. Where did the coffee come from? That's what this code is like. Why does render have a side effect of setting the value of this is sweet? When is this is sweet read back in test page and include? Yes, it does. In both, In neither? If it does, yes. Okay, so that is a really good point, which is, if you look right here, this right here is used further down, which just becomes confusing, right? So, but not only that, but it sets the state of this thing until someone sets it differently, right? Like, that's also super confusing. Like this whole stuff, Java, I love it. Martin changes in this very chapter that it makes sense to break a function down into smaller functions if you can extract another function from the name with a name that is not merely a restatement of its implementation. But then he gives us this, is test page. I agree. I agree with that. Oh, have I skipped something? Let's see. How would you unit test this method? Well, you can't. It's not a unit. It can't be separated from side effects that it has on other parts of the code. And what's up with the indentation? And where are the dang braces? Exactly, dude. I was thinking about that dang braces. I didn't want to say anything, but yes, I agree. Is number larger than 10? Oh, no. Private wiki page, find inherited page. You know, I used to program like this. I did. I was affected by clean code. I went to college during the clean code phase. I was in the Java phase. I did all this. I was getting a master's in software engineering at once, and it was all like this, and I used to write code like this, and I just hated my life, and I couldn't figure out why I hated it. A half dozen others that say, okay, let's see, there's at least one questionable aspect of this code isn't Martin's fault. The fact that page data contents get destroyed, unlike the member variables, is sweet test, blah, 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 blah. Page data is not actually ours to modify. It's originally passed in at the top level render methods by an external caller. The render method does a lot of work and ultimately returns a string of HTML. However, during the work, as side effects, page data is destructively modified. Surely it'd be preferred to create a brand new page data object with our desires. Our desired modifications and leave the original untouched. If the caller tries to use page data for something else afterwards, they might be very surprised about what happened to the contents. But this is how the original code behaved prior to the refactoring, and the behavior could be intentional. Martin has preserved the behavior, though he has buried it very effectively. Interesting. I used to get harassed by middle management and junior devs about the need to have clean code, and they won culture battles for a while. Yeah, it's true. Some of the mild puzzles, okay, so this is just like a whole bunch. Let's see, is there something more? Okay, anyways, let's do this. Pretty much, clean code mixes together a disarming combination of strong, timeless advice and advice which is highly questionable or dated or both. Much of the book is no longer of much use. There are multiple chapters which are basically filler, focus on laborious work examples of refactoring Java code. There's a whole chapter of examples of refactoring Java code. There's a whole chapter examining the internals of JUnit. This book is from 2008, so you can imagine how relevant that is now. There's a whole chapter on formatting. Yeah. Pick a sensible standard formatter. Yeah, why would you even do that? Why would you ever? Yeah. The content focuses most exclusively on object-oriented code to the exclusion of other programming paradigms. Object-oriented programming was very fashionable at the time. Yep, it was. Was a huge proponent of OO, having invented 3 of the 5 principles which make up solid, and having popularized the term, but totally absence of functional programming techniques or even simple code procedural code was regrettable even then and has only grown. Yeah, I love procedural code. Real talk, I love procedural code. Procedural code is fantastic. I love it. I love procedural code. Anyone, this whole idea that somehow it's bad, like there's this notion that I had in my head that it's bad, and I realized I don't think it's bad at all. Like a lot of stuff you can do can be done procedural, and it's great. You know what I mean? It's fine. OOP is disgusting. Rust is procedural. Yeah, pretty much most things are procedural. They're not quite functional. Most people think what they're doing is functional. They're actually doing is procedural. It's very, very interesting. Step 1, do this step. Step 2, do this step. Step 3, you did stuff. Procedural code is just like do X, do Y, do Z, do A, do B, do C, do D. The end. Right? Pretty much C is procedural max. Yeah, C you can kind of turn into functional. Anyways, the book focuses on Java code to the exclusion of other programming languages, even other object-oriented programming language. Java was popular. Yes, it was very popular. And at the time of the writing of the book, this makes sense. Yep, I agree with all that. But the book's overall use of Java is very dated. Well, yeah, it's because Java's changed so much. This kind of thing is unavoidable. Programming books date legendarily poorly. 2 LYs always makes a word difficult to read. That's part of the reason why clean code was recommended read at one time, and now I think the pendulum is swinging back in the opposite direction. Yeah. But even at that time, even the 2008 era Java, much of the code is bad. There's another chapter on unit testing that there's a lot of good basic stuff in this chapter about unit testing should be fast, independent, and repeatable, about how unit tests should enable more confident refactoring. I really am not sold on that one, about how unit tests should be about voluminous as code under tests, but strictly simpler to read and comprehend. So I have some pretty general rules about code, unit testing. Unit testing should be as declarative as possible, right? I think that's very, very important. If you find yourself doing logic in unit tests, you've jumped the shark in the usefulness. 3, unit tests are almost exclusively not useful during refactoring. And the reason why I say that is because when you refactor, you change the unit, almost always. And so more functional level or integrational level testing tends to be way better for refactoring. If you have really good integration level tests that test the entirety of your program, you can go nuts. Then you're doing unit tests wrong. Not necessarily. Unit tests literally mean units, right? Like, it can just be a function that does something complicated. I test stuff at the function level, but when I refactor, often that function goes away in principle because I vastly changed the orthogonal nature of my program, and thus unit tests aren't useful. I don't think that level of testing is useful for refactoring. I've never thought it was useful at the function level, but I do find integration tests amazing for refactoring because they always just keep doing the same thing. Writing good unit tests, I learned a lot. Yeah, you can. I mean, I'd have to look at what it has to say. I test on a live server. I think live servers is really good. Agreed with you when you say refactor, you need to change all the tests anyways. You need to change the tests so often. Anyone that says you don't have to change tests, I just feel like you haven't refactored enough. Oh, crap. Oh, crap. Oh, crap, people. I got a meeting. I got to go. I got a meeting. We can't finish the article. Good article, but I can't finish the article. Got to go. I'm going to just almost picked Pokemon. I'm going to do Christopher Titus Tech. We're going to go right here. We're going to take this. I got to go. I got to go. I'm late. Oh, shoot. Oh, shoot. Shit, meeting. Run.